stretched or compressed object. So what kind of energy is stored in
Elastic.
excellent.
Elastic.
So
Elastic potential.
that is elastic potential has stored in a spring. Yeah. Then battery. What kind of energy is associated?
Chemical.
कोई और भी आंसर
Chemical.
देगा that is chemical energy. Excellent. Potential. Okay. Then temperature of an object,
Thermal energy.
thermal energy, light of an object. So it's basically light energy. ठीक है. Principle of conservation of energy is considered a universal law of physics. That is true for all scenarios. According to this principle, energy cannot be
Created or
created
destroyed.
or destroyed. Zabardast. Energy can be
Transformed.
transformed or changed from one form to the other or transferred from one body to the other. The total amount of energy available in a closed system is
Constant.
constant. So what is a closed system, by the way?
So a system from which outside energy cannot enter and energy which is inside cannot escape.
दोबारा बोलें.
So a system into which any outside energy cannot enter or
Excellent.
जो अंदर energy it can
Any example?
escape.
Any example for a closed system? There is a system. Okay, then when we say that energy cannot enter or leave that system, that is a closed system. Okay, that's clear. But any energy for a closed, any example for a closed system? No example.
Sir, a cooking pot with the lid closed.
Excellent. A cooking pot with lid.
Closed.
A thermos flask. Is it possible that we consider a thermos flask as a closed system? Have you seen a thermos flask? A container that is used to store what? Tea, hot tea. It's like a jug. I know. Ever seen that? Come on, people.
Yes, sir.
So it says in the real world, there are both energy dash to any system and energy dash from the system. So there may be energy supplied to any system in the form of work done, and then energy lost from the system in the form of friction and resistance, light or sound. So whenever there is an object that is doing some work, so energy is supplied to that. So for example, let's say there is a car that is being driven on the road. So energy is supplied to that car, and that car would dissipate its energy based on some heat losses, frictional losses, light losses. Okay, do we get this? Then it says we will need to factor these into any energy calculations we carry out. Mathematically, this principle can be applied as follows. Sum of dash energies in this. What energy? Initial plus work done to the system equals sum of final energies in the system plus energy what lost from the system. So let's say we discuss an example here. So there is a car. Okay, car runs on fuel. So let's say that fuel provides 100 joules of energy to this car. So that's the initial energy. And then let's say that engine displaces this car from one point to the other. So that is the kinetic energy. So let's say 100 joules of energy according to the fuel is supplied to this car. And as a result, this car creates a kinetic energy of 10 joules. So total energy of this car would be 100 plus 10. That would be 110 joules. Am I understood better?
Sir, please repeat one more time the whole
Okay.
thing you did.
See, for example, if there is a car, we believe that car runs on some kind of fuel. Am I right? So every fuel, be it petrol, be it diesel, be it kerosene, be it gas, it supplies some energy. So I've taken that energy supplied as 100 joules. For example, if that car runs on a fuel and that fuel supplies 100 joules, and by taking that 100 joules, that car displaces or moves from one point to the other. So car can have kinetic energy plus the energy supplied through the fuel. Am I right?
Yes, sir.
So that's the energy, initial energy, that's 100 joules coming from fuel. Then that car is doing some work, so that's 10 joules. So overall, it would be 110 joules.
112.
Okay.
Okay.
And as a result, what happens, that car, moves up and it ends up to some, let's say, position where we want to be there. Then that fuel basically is used up. So what we believe is, in traveling from point 1 to point 2, not the final destination, energy of the system would decrease. So let's say now that fuel that's supposed to be, was of 100 joules is now burnt, and let's say 50 joules is left in terms of fuel. So that's the final energy. And how much energy is lost? Anyone? If 50
Sir,
joules is
if-
left in terms of fuel, starting from 100 joules,
sir,
so how much? 60
sir, 60 बाकी रह जाएगा ना?
exactly. Zabardast. So since it was 110 initially, overall, so it would be 110 funding. Is that correct?
This is lagging.
Hello. 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 Hello.
Sir, आप सही आ गए बस.
Okay. So if I'm saying
Sir,
that
आप सही आ रही है.
I'm saying that it was initially 110 joules and 50 joules is left in terms of fuel's energy, then how much energy is lost? That is 60 joules, because energy can neither be created, it cannot be destroyed. So it has to have a balance.
Sir,
Yes. Hello. Yes. Anyone was saying anything?
सर मैं कह रहा हूँ ये आपके आवाज बहुत लैग हो रही है.
Okay. Sure. अब सही हुई? Hello. Is it okay now? Hello.
जी सर.
Okay.
Yes,
हम
sir,
कह रहे
sir.
थे कि initially it was 110 joules, 100 from fuel and 10 from the work done. That's the kinetic energy. So what's left? If 50 joules in terms of fuel is left, then 60 would be lost. Am I right? Because mathematically, whatever you supply has
Yes.
to be same finally. Is that understood from everyone?
Yes sir.
Can I move on?
Yes.
Okay. So now, yeah, it says there is some car with 20 kilojoules of energy. Initially, it travels up an inclined road. Its engine supplies an additional 10 kilojoules for a short while. Okay. Assuming there is no loss of energy to the surroundings, explain the final amount of energy possessed by the car using the
इस तरह हो जाएगा
principle
कि-
of conservation. Yes, बोले.
Sir, initial energy is 20 joules plus work done is 10 joules. तो 30 kilojoules हो गया ये.
Excellent. That's the initial and that's the work done. आगे.
सर उसके बाद फाइनल एनर्जी आ जाएगी.
कितनी आई?
सर 30.
That's the final energy, and then there is no loss. है ना? So loss 0 हो
Yes, sir.
जाएगा और final 30 हो जाएगी. So final amount of energy would be 30 kilojoules.
30.
Is that understood?
Yes, sir.
Okay. How would you define efficiency?
सर लेकिन सर एक सवाल है नहीं सर क्लियर हो गया सॉरी क्लियर हो गया
Okay. How would you define efficiency?
The useful output upon total input multiplied by 100.
Excellent. So it's useful output over total input. So I can define it as percentage. You know, आपकी भी definition सही है, मैं भी जो लिखवा रहा हूँ वो भी अभी देखते हैं आपको समझ में आती है या नहीं आती. So percentage of input energy that is converted into useful output energy. सही है. Since efficiency is expressed as percent, so I've defined it as percentage of whatever you supply that has been utilized into some useful output. Am I right? वो भी बिल्कुल सही थी जो आपने बोली थी. You may write that. Totally okay. What's the formula for it? Hello, are you guys here?
Yes, sir.
Okay. What's the formula for efficiency? That's the symbol for efficiency. Eta. Okay.
Output upon input into 100.
Not only output upon input, but useful output. Okay. Over total energy input. What's the difference between useful output and only output?
आउटपुट में दो चीजें आ जाती है ना यूजफुल और वेस्टेज
Excellent job, excellent job. हम efficiency calculate करते हुए weight loss को कभी भी add नहीं करते. We have to subtract it every time. Okay. For example, if there is a car that supplies us with 10 joules of useful output and 100 joules of heat loss. So we won't be using 110 as the numerator. We would only be using 10 as the numerator. Okay. Is this clear to everyone? Can
Yes,
I
sir.
move on?
यस
Yes, sir.
Okay. Then it says a refrigerator that is 80% efficient requires 800 kilowatt to operate. This means that the refrigerator is able to convert what? That's a good question. Let's see who answers this.
सर प्लीज रिपीट द क्वेश्चन
It says a refrigerator that is 80% efficient requires 800 kilowatt to operate. Okay. What does this mean? Refrigerator is able to convert dash percent watt.
सर ये इसका हो जाएगा आउटपुट 800 किलोवाट डिवाइडेड बाय
No. It is able to convert 80% of 800. सही है? Okay. So what's 80% of it?
640.
Excellent job. Who was this? Who was this?
Sartaha.
Okay. So 640. Do you know how to calculate, 80% of 800?
कैन यू प्लीज टेल वन टाइम
80% times 800. So this would be 0.8 multiplied by 800. Okay.
ओके सर
Then it says of the total electrical energy into useful work and dash percent of is lost. What percent is lost?
20.
20% is lost, and that is
160.
160. How is this 160? Because you were supplying 800. Out of that, 640 was used. You know, useful.
Yes.
So what's
अब
left?
बचा ही शायद 160 बचा सर.
Okay. What is calm?
Sir, work done is in joules.
Yeah. Okay. Zabardast. But I'm asking, what is calm? Do you know how to define this? No ideas? It
Sir,
The
is.
work
इसका
done is the
formula
product
तो
of
पता है.
force applied and the distance traveled in the direction of the force applied.
Yes. So it is defined as the product of force
Force into distance.
and the distance moved by the object in the direction of.
सर इसमें वो पैरेलल वाला नहीं होता.
हाँ लिख रहा हूँ मेरा बच्चा वही लिख रहा हूँ, इन द डायरेक्शन ऑफ द फोर्स. सही हो गई बात, पैरेलल हो गया, यानी कि इस ऑब्जेक्ट पे अगर ऐसे फोर्स लगेगी और तो ये ऐसे ही आगे जाना चाहिए, है ना?
जी सर.
व्हाट इज द फॉर्मूला फॉर वर्क डन?
वर्क W equals F into D.
F into S.
और मे बी डी, इट्स अप टू यू, टोटली ओके, कोई मसला नहीं. ठीक है. अच्छा, व्हाट इज द यूनिट ऑफ फोर्स
Newton.
एंड व्हाट्स द यूनिट ऑफ एस और डी?
Meter.
Meter. So Newton meter becomes what? Joules. Okay. Okay. Then it says when an object moves in the dash of the applied force, work is done. Right, simple. The direction of the applied force. However, when the object does not move or moves in a direction perpendicular to the force applied,
No.
no work is done. Excellent job. Because you know, if this is the force applied and let's say that's the displacement, so we would say it's a 90-degree angle and then it becomes 0. So we consider only work that's in the direction of the displacement. Okay, only parallel direction. That's it. No other direction. Got it? Work is done equivalent to what?
Energy supplied to the system.
Excellent. How much energy you are consuming would be converted into work. And then now that depends that whether that work is useful or useless. Graphically, work done can be calculated from dash under a FS graph.
Sir, ये नहीं समझना है.
They're asking if we were to calculate, you know, work done through a graph. So let's say that's force and that is displacement. That is force and that is displacement. So how would we be able to calculate work from this graph? So we use the same F into S. We use the same F into S. You know, so that represents
Yes.
what? Let's say this becomes the length, and let's say this becomes the breadth. So we are multiplying length and breadth. That becomes what? Area. Am I right?
Area.
So I can
Yes,
write
sir.
simply that if I want to calculate work from a graph, I can calculate it using
Area.
area. You got this? Hello.
जी sir.
Yes, sir.
So that's the
Yes, sir.
area or that's the work done in terms of this, you know, graph, and that is maybe the work done in terms of this graph. So if I shade it accordingly, I can label this as work. Got it?
Yes, sir.
Okay.
Yes.
Salman Khan. Is Salman Khan with us? Salman Khan is, you know, is not with us. So, okay. Adil Ahmed. Are you with us?
Yes.
Adil Ahmed, can you repeat what was discussed just now? how do I calculate, you know, the work from a graph? Adil. Adil doesn't know that. क्या करूँ आदिल?
Sir,
आदिल
मैंने
has
check
left the
में
class. हाँ क्या हुआ? जी बेटा आपका
मैंने
बोल.
check में
I
सिर्फ
haven't left
area
the class.
दिया।
My mic stopped working.
क्या? Sorry, what?
I did not leave the class. Its area mic stopped working.
Can you please repeat? I'm so sorry. I didn't get you still.
सर वो क्या है उनको माइक वेट नहीं कर रहा, उन्होंने एरिया चैट में लिख दिया उसका आंसर।
चैट में तो
उन्होंने
बेटा
explain
आपको
किया।
चैट में तो पता होना चाहिए कि मैं सिर्फ जो है वो क्लास में माइक पे बात सुनता हूँ. चैट पे अगर मैं लिख के पढ़ाने लग गया बेटा तो हो गया काम. अच्छा ओके. रयान अहमद, आर यू विद अस?
Yes, sir. Sir,
Okay.
I just got connected because I was disconnected. मैं अभी कनेक्ट हुआ सर थोड़ी देर पहले ही, एक
Okay. Okay.
मिनट.
It says gravitational potential energy and kinetic energy are collectively known as what? Yeah, that is a good question. So they are known as mechanical energy. Kinetic energy can be calculated
आपने
using.
वर्कशीट से प्रैक्टिस के लिए कराया ना?
हाँ, इसके बाद क्विज पे जाएंगे ना, क्योंकि वर्कशीट अगर आएगी तो क्विज होगा ना.
ठीक है
ये हमने सब क्लास में किया था ना, तो मुझे
जी
उसकी
सर, जी।
आंसर की डिस्कस करनी थी आपसे, रिमेंबर.
ओके सर।
So where m is what? Mass. E is what?
स्पीड।
Speed. कोई velocity तो नहीं बोल रहा ना? Speed. Because
sir.
velocity is a vector quantity and energy is not a vector quantity, it is a scalar concept. Okay. Gravitational potential energy near the surface of the earth can be calculated using this formula where m is what? Mass. What's G?
मास,
Sir, mass,
Gravitational.
gravity,
Gravitational
Gravity.
field strength. Zabardast. What's H?
sir,
Height.
height.
Height. Zabardast. Often in a purely mechanical system, the energy change involves a gain in gravitational potential energy, which results in
लॉस
dash.
इन काइनेटिक एनर्जी।
अरे वाह जबरदस्त, सीधा चल लो लड़के. Loss in kinetic energy or a loss in gravitational potential energy, which results in what?
मोर
Gain in kinetic energy. Excellent job. Excellent. ये बताओ, ये मैं सिर्फ अरकम को पढ़ा रहा हूँ या बाकियों को समझ में आ रहा है, बाकी सो रहे हैं? ताहा,
Whether be
यार,
sir, समझ में आया सर, नोट करता हूँ.
सही है, सबको समझ में आ रहा है, पक्की बात है. इब्राहिम शुएब, मोहम्मद अयान, मुनीर इमरान, आदिल अहमद, इब्राहिम शाह, ताहा जावेद. नो रिस्पॉन्सेस. क्या करूं? वेटिंग रूम में डाल दूं?
नहीं सर,
सर मैंने तो रिस्पॉन्ड किया था.
आ रहे हैं सर.
अच्छा जी, आगे चलते हैं. बेटा ये साथ साथ न्यूज कौन सुन रहा है? Okay. It says a 100-kilogram roller coaster car is at rest near the top of a 20-meter high track. It is released and travels to the bottom of the track. Determine the kinetic energy of the car at the bottom of the track. Assume that the energy lost due to friction between the wheels of the car and the track is 100 joules per minute. Using the principle of conservation of energy, initial kinetic energy, initial gravitational work is equals to क्या क्या लिखो हुए values बताओ.
सर काइनेटिक एनर्जी की वैल्यू तो निकालेंगे ना?
Kinetic energy के निकालेंगे, ठीक है, तो इसको x कर देते हैं फिर, क्योंकि ये हमें पता नहीं है. क्या करें?
एक सेकंड। सर आप एनर्जी लॉस की जगह तो वो लिख देंगे ना
100
सर
100 जूल।
इनिशियल काइनेटिक एनर्जी 0 नहीं होगी?
इसको 0 कर लेते। मुझे तो जो आप बताएंगे वो मैं लिख दूंगा।
सर वो रोलर कोस्टर रेस्ट पे है ना, तो फिर वो 0 होगी।
ठीक है, और इनिशियल ग्रेविटेशनल पोटेंशियल एनर्जी की जगह पे ऑलरेडी mgh लिखा हुआ है, वर्क डन 0 हो गया। ठीक है, फाइनल काइनेटिक एनर्जी हमें नहीं पता, फाइनल ग्रेविटेशनल पोटेंशियल एनर्जी 0 लिखी हुई है और एनर्जी लॉस 100 लिखवा दिया। ठीक है, और फिर नेक्स्ट क्या है, डैश जूल्स प्लस डैश जूल्स इज इक्वल्स टू फाइनल काइनेटिक एनर्जी प्लस डैश जूल्स। क्या करूँ फिर?
ये तो समझ जाएगा ना कि 0 जूल्स प्लस mgh इक्वल्स।
mgh की जगह पे वैल्यू लिखनी है, नहीं लिखनी है?
सर वैल्यू निकाल लेते हैं ना अभी।
m कितना है?
100 into 10 into 20।
ये नहीं पता हमें। ठीक है, प्लस क्या लिखूँ? 100।
जी सर।
फाइनल काइनेटिक एनर्जी कितनी आई?
सर एक सेकंड, सर इस साइड पे तो 20,000।
Sir, 19,900.
ओके, कोई करेक्ट करेगा इसे भाई, या ये सही है?
नहीं सर 20,000 ओवर 100 होगा ना।
50,000 ओवर 100 होगा, क्यों भाई?
सर आपने स्क्रीन शेयर ही हटा दिया।
स्क्रीन शेयर
हाँ
हटा
सर,
दिया?
जी सर।
तो क्या हुआ है? समझ नहीं आया।
सर मेरे पास भी नहीं आ रही थी।
एक
Sir, मेरे पास भी नहीं है।
एक मिनट सबर करो, सबर करो। सही है, आगे स्क्रीन आ गई।
जी सर।
जी sir.
हाँ, तो हमारा आंसर क्या
जी
आया था?
सर आ गया।
19,009। दैट वाज करेक्ट।
सर सही सही आंसर है।
हाँ भाई, मुझे पता है आप बहुत अच्छा पढ़ रहे हैं माशाल्लाह से। अल्लाह ताला आपके इल्म में और इजाफा फरमाए। सही है, आगे चलूं? क्या ये सब शहजादों को समझ में आ गया?
जी सर।
जो लोग
जी
सो
सर।
रहे हैं उनको भी समझ में आ गया, जिन लोगों का माइक नहीं चल रहा उन लोगों को भी समझ में आ गया, जिन लोगों की वीडियो ऑफ है सब कुछ समझ में आ गया? मुझे सबका रिस्पांस चाहिए। रयान का तो आ गया यस, यस आया, यस, यस नहीं आया। अब्दुल अजीज, बेटा माइक ओपन कर लिया, बोल भी लो। कोई आवाज नहीं आ रही। बिलाल, बिलाल मिर्जा, आर
Yes
यू विद
sir.
अस? समझ आ गया?
Yes.
इब्राहिम शुएब,
Sir, मैंने तो जवाब बताया था.
तो ये भी बात सही है यार। और ताहा जावेद, रैयान अहमद, ताहा जावेद कहाँ गए? गायब हो गए?
सर मैं यहीं हूँ।
समझ आ गया?
जी सर।
ओके, गुड। ये बताएं कि कितनी रह गई? ये रह गया लास्ट। व्हाट इज पावर? बहुत सारे शहजादे जो है ना क्विज वाले दिन पावर का फॉर्मूला ही भूल गए थे।
रेट ऑफ वर्क डन।
रेट ऑफ वर्क डन। जबरदस्त।
हेलो सर, आवाज आ रही है?
जी जी आ रही है।
बस सही है।
रेट ऑफ वर्क डन। व्हाट्स द एसआई यूनिट?
वॉट।
Watt.
Sir, what?
What's the formula? It is given. Work done per unit time. P is power. W is amount of work done.
सर वर्क डन टाइम।
And T is time. ठीक है, अच्छा अब इसका आंसर बता दो जल्दी से लास्ट। तो सबसे पहले तो आई कैन कैलकुलेट वर्क, दैट इज पावर मल्टीप्लाइड बाय टाइम। पावर कितनी दी गई है? 2000 लिख
सर
दो।
मल्टीप्लाई बाय 5 5।
Sir, 2,000 watts.
1000 5 5 से क्यों मल्टीप्लाई करूंगा टाइम तो
Sir,
सेकंड में
5
होगा
into 60.
5 times 60 हो so that would be
300.
हाँ
Yes.
5 है ना सही लिखा है ना 6 5 30 32 60 बाकी 4 और 1 5 0 सही लिखा है ना वेलोसिटी निकालो वेलोसिटी कैसे निकालो so it says a frictionless horizontal surface that means no loss अब लॉ ऑफ कंजर्वेशन ऑफ एनर्जी क्या कहता है इनिशियल काइनेटिक एनर्जी प्लस काम
Work done.
इज इक्वल्स टू क्या लिखूं फाइनल काइनेटिक
Final
एनर्जी
energy.
प्लस 0 सही है
Yes, sir.
तो इनिशियल काइनेटिक एनर्जी क्या होगी 0 काम कितना आया है 1 2 3 4 5 फाइनल काइनेटिक एनर्जी कैसे निकालेंगे हाफ एम बी स्क्वायर तो डू वी नो एम
Yes, sir.
मल्टीप्लाइड बाय 2 डिवाइडेड बाय m कितना है 1 एक्सपोनेंट 3 इज इक्वल्स टू v स्क्वायर सही किया है मैंने ये 2 राइट हैंड साइड पे डिवाइड हो रहा है लेफ्ट साइड पे आके मल्टीप्लाई हो जाएगा m यहाँ पे मल्टीप्लाई हो रहा है राइट साइड पे लेफ्ट साइड पे आके डिवाइड हो जाएगा am I right 2 6 12 2 0 ज्यादा तो 1200 आ रहा है v स्क्वायर v कितना आ जाएगा स्क्वायर रूट ऑफ 12 कितना आ रहा है